Okay, we are starting with Leetcode number 419 or battleships on a board. Given an n times n matrix board where each cell is a battleship X or empty period, return the number of battleships on the board. Battleships can only be placed horizontally or vertically on the board. In other words, they could be made up of the shape 1 times k, 1 row, k columns, or k times 1, k rows, 1 column, where k can be of any size. At least one horizontal or vertical cell separates between the two battleships. So basically, this whole paragraph, the second paragraph, is saying that we could only have battleships that are horizontal, like this, or vertical, like this. What it's also saying is that we can't have two battleships adjacent to each other. There will always be a column or a row which separates them. So in this case, we'll never have a battleship like this, right? So there won't be two battleships that's next to each other like this. This will always be one battleship. So our main goal is to scan through this whole entire matrix and find every single battleship on the board, count them up, and return it in the end. Okay, so this is my Java approach. In this approach, I use DFS or depth first search instead of BFS. You can use both breadth first search and depth first search, but I feel like depth first search is much easier for this problem, especially if you're first learning DFS. This is an easy problem to attack just to help introduce the basic concepts of DFS. So what we do first is that we declare an int variable ships, which keeps track of the amount of ships we are going to return in the end. So that's our main variable that we need to keep track of. And my approach is a O of mn. M is the number of rows and n is the number of columns approach, which means we always go through the matrix only once using DFS. So these two for loops here just go through each index of the array, right? So we start from the first, 0, 0. So starting from the first, we are here, right? We're at 0, 0. So starting from 0, 0, we see that the character in that index is an x. And since it is an x, we go through the function DFS. We pass in the 0, we pass in another 0, or the row and the column, and then the board, the main board which was passed into us. And then we increment the number of ships, but we'll see why after DFS we do that. So once we're in DFS, we get the row, we get the column, and we get the board. Remember in Java, matrices are passed by reference. So anything we do to board in this function will change it in this function up here. The first thing we're going to do is go through this if statement and we check the edge cases of the row and column. So if row is greater than or equal to 0, if column is greater than or equal to 0, if row is less than the board length, if column is less than the board length, and if the character at that particular index is a battleship. And if it is a battleship, then we go through what is under the if statement. So in usual DFS approaches, we use a visited Boolean matrix of the same size. But in this case, we could change the ships in this matrix to show that we already visited it, right? So since we know that this right here is an X right now, and we only visit here and here, if it is a battleship or if it is an X, we could just change it to a period to know that we already visited it. So after we change this to a period, or let's say an open C, we check above one, we go below one, we go to the right one, and we go to the left one. So basically, we're seeing all around the X that we found to see if there's any more X's. And if there are, then we change that to a period also. So again, we go above one, but since that's out of bounds, we don't do anything. We go below one, that is in bounds, and that is less than the board length, but this is not a battleship as it says here, since this is a period. So we don't go in the if statement. We go to the right one, and that's the same thing. Every edge case is satisfied except that it's a battleship, so we don't go in the if statement. And then next we go to the left one, but as you can see, it's off the board, which means it is in the sea. So in this case, we only have one battleship, right? And the battleship is only of length 1. There was nothing to the right, below it, above it, or to the left, right? And we keep doing that for every single X on the board. So now we're back to this for loop up here, and we're going to increment each index, remember. So now we are here in this part of the sea, but this isn't an X, right? So we keep going. We're now in this part of the sea. This isn't an X, but now we go to the right one, and that is an X. And basically, our DFS approach will make every part of that ship a C, right? So in our DFS approach, we start here, we check every direction from it. So up, to the right, down, and to the left. So since to the left is to the C, we don't do anything. Above and to the right are off the board, we don't do anything. Below is an X, so it satisfies every edge case in our if statement. So we do take this out and we put it as a period instead of an X. Now we do the same thing here. We go down one, we go to the right one, and we go to the left one. And as we could see, there's only one way we could get to the X, and that's down. And we take that out also, and that is where we stop because there's no more X's anywhere around it. And remember, once we're at this X, we can't go up again, right? Because once we go up through DFS row plus one, this X right here is actually, we change it to a period, remember? So we can't go up one, and it will not satisfy this part of the if statement, board row column equals X, because it's not a battleship anymore since we already know there was a part of the ship there and we changed it to the C. So now going through the for loop, we are now at this index right here, which is 1, 0. Now we are at 1, 1, 1, 2. Since these are all part of the C, now we are 1, 3, right? But remember, this is passed by a reference. So whatever we did to board right here, it will change the board for the whole entire class. So now this is actually not an X. It is the C. So we will just pass by it like it's any other part of the C. We go here, and now as you can see, same deal with this X right here. This is part of the C now, right? Since we already visited it. So now we go through each index, and we're finally at the end, and our ship's incremented twice, right? Because we found two X's. We found this X right here, and we found this X right here. And that is our two ships, which we return at the end.